Yeah, so let's start. I think it's we waited for 5 minutes. Yeah, let's start. Let me know if you guys can see the screen. I'm sharing it. You can see the screen, right? So you guys can speak out because I cannot see the chat messages while I'm sharing the screen. Okay, cool. Um, let's start. Okay, so yeah. Um, So I'll right away start with the assignment problems. Right. So yeah, there are. I think they're easy to hard. I would say. Yeah. So this one should be easy. So there are two boxes B1 and B2. Now box one B1 containing four red and four blue balls and two green balls. Overall, there are 10 balls in the box one. And in box two, you have two red balls and three blue balls. And one ball is drawn from each box B1 and B2. Right? So you draw one ball from box B1 and you draw one ball from box B2 and identify the true statements. I have given the solution here also, but yeah. So let's see. Um, anyone of you guys want to try? What is the probability that if you draw ball from B1 that it is red? Oh, sorry. The probability of draw. What is the probability of drawing a red ball from B1? That way. Right? It is 4 by 10. Anyone wants to, anyone would like to volunteer why it is 4 by 10? As you can speak out, as I mean, it is good if it is interactive. Um, right? Why the probability that uh, drawing a red ball from B1 is 4 by 10? Anyone? Okay, so let me explain. Because you have only four red balls in B1, right? And you have in total 10 balls in box B1. So you can pick any one of the red ball in four ways. And in total, you can pick any one ball out of 10. Right? That's why it is 4 by 10. Right? What if I change this question to say uh, I pick two balls from box B1 and all two of them are red. Right? So what would be the answer in this case? Anyone else? Yeah. If the question is changed to say you pick two red balls and you saw two red balls are right. So are red. What is the probability that uh, we are only looking at box B1 that contains four red, four blue, two green balls, and now you are drawing two balls from B1 and you observe those two are red. So what is the probability of that event? Anyone? Like it is simple because you are choosing two red balls, right? You can choose two red balls um, in six different ways, like four choose two. Uh, Yeah, I think 2 or 15 instead of that. I mean, I'm not sure what, but it is 4 choose 2 by 10 choose 2, right? Yeah, if it turns out to be that, then that's the case. Um, okay, so next point two. What is the probability? Probability that blue in B1, right? You draw one ball and you see B1 blue. What is the probability of that is happening? It is again 4 by 10, uh, not 5 by 10, right? So, right. Another question is probability of green in B1, right? It would be 2 by 10 because you have only two green balls. You can pick any one of them in two ways, but in total 10. That's why it is denominator is 10. And probability of red in B2, that is 2 by 5, right? So, yeah. Any questions on this thing? This is relatively very easy question, right? So, anything, uh, any questions we can discuss, or we will move to next question. Okay, yeah. So omega fp is the probability space. As omega denotes the sample space as usual, f denotes the collection of subsets of omega that satisfy certain rules, right? Basically closed under complements and countable unions, um, right? F satisfies the properties. So which of them is a valid sigma algebra? Anyone wants to um, write out this? 1, 2, and 4. 2 and 4. I think even 3 also. Why it's right? It is closed under complements and quantum units. Okay, so P of omega denotes PP is a strip matching, but it means a different context here. It means the power set of this omega, right? So it has all the possible subsets, right? Which is 16 elements you get. So by default, power set is sigma algebra, right? And phi omega is phi is nothing but the empty set. Phi omega is a trivial sigma algebra, right? And yeah, even third is sigma algebra and fourth is sigma algebra. To verify that, you have to see these three properties hold. Like omega belongs to F and any A belongs to F. A complement should also belongs to F. If AI is belongs to F, union of AM should also belong to F. So basically, these two are, you can say that, closed under complements and countable unions, right? And okay, so this is another problem. It's like you are enter a chess tournament where your probability of winning a game is zero point 0.3 against half of the players. Right? You call them type 1. And zero point 0.4 against the quarter of the players. I call them type 2. And zero point 0.5 against the remaining quarter of the call them type 3. You play a game against a randomly chosen opponent. What is the probability of winning? Yeah, yeah, please. What is the doubt? I mean, you can speak out instead of typing. C is valid. Okay. Yeah, so um, it satisfies all these three properties. What is it? Yuvraj, right? Um, I guess that's the explanation. Basically, I think it should exist. It exists, right? Yeah, yeah, I think. eh, yeah, I think. Yeah, yeah, yeah. So I think you are correct. Yeah, that's my bad. So C is not valid. Yeah, right. One, two, and four are the valid signal. Any clarification needed? Yeah. So BCD is not present in that set. So that's why C is not a signal. That's true because omega belongs to F. Omega complement is phi. That's why it should belongs to F. Yeah, and they are there in C. Any questions? Okay, cool. So let's go to next problem. Yeah, so this is a chess tournament, and the probability of winning a game is zero point 0.3 against certain type 1 players, zero point 0.4 against type 2 players, zero point 0.5 for type 3 under players. You play a game against a randomly chosen opponent. What's the probability of winning? Right. So I've written down the solution here. Yeah, so basically here it's a straightforward question. If A is the event of winning, right? You can, I mean, you don't know which player you end up, which type of player you end up playing with, right? So here we have three different possibilities. Given that you will encounter a player of type 1, probability of winning is zero point 0.3. And again, type 2 player probability of winning is zero point 0.4. Type 3 player probability of winning is zero point 0.5. Right? So and what is the probability of choosing a player of type 1? I have written it as zero point 0.5. Does anyone of you understand why I have written it as zero point 0.5? You can speak or yeah, you can type in chat box. Right. That's because it's half the players, right? It's given already here, whatever I'm highlighting, and quarter of the players here, and remaining quarter. Type 2 and type 3 are their quarter each. That's it. So probability of winning is just you averaged out all the possibilities, right? And this is it, and you end up getting this much. This is the answer. Right? You know why I have written this, I guess, or you want me to explain why I have written this? So far, all good. Okay. Yeah. The patients are recruited out on two terms as a control and treatment of a clinical trial. Zero is control and one is treatment. Now, the probability that an adverse outcome occurs on a control arm is P0 and P1 for treatment arm. Patients are allocated alternatively onto the two arms and their outcomes are independent. What is the probability that first adverse event occurs on the control arm? Here you can assume that you start with the control arm, right? At least the solution which I have written assumes that. Yeah. So here, this is how it has been done. Whatever I've written, we reason out this. Your it can happen. You can encounter this thing in first go itself, right? The probability of happening um, uh, adverse outcome can happen on the first term, that is P0. But if it doesn't happen, right, it doesn't happen with probability P1 minus P0. It should not happen with P1. Again, it can happen with P0. So this will go on. Then this is a geometric series, and the desired event is straightforward. Um, any more questions on this? And go for, yeah. So this is an interesting question. Okay, which part you are confused with? Yeah, okay, the expression is it? Okay, right. So A is the event that the first adverse event occurs on the control arm, and I'm stating that you start this process with the control treatment, control treatment, right? Now, when you start with the control, uh, when you start the first with control, the probability that adverse event can happen on that is P0. Right? That is given in the problem, right? It can happen in the first time itself. If it doesn't happen in 1 minus P0, and it should not happen on the treatment arm, that happens with 1 minus P1. But then it can happen on P0 with probability on control arm with probability P0, right? Again, plus what will happen is it will not happen with P0, it will not happen with P1. Again, it will not happen with P0. Again, it will not happen with P1. But then it will happen with P on control arm with P0. Is it clear? Right. Um. Okay. Thanks. Uh. Yeah. So this is yeah, this is an interesting question. Okay, omega is a complex cube root of unity, which is not equal to one, of course, right? And a failed die is thrown three times. And if R1, R2, R3 are the numbers obtained on the die, then what is the probability that omega power R1 plus omega power R2 plus omega power R3 is equal to 0? Okay. So, yeah. So, this is a problem, right? For this, to solve this, you should know a couple of things regarding cube root of unity. I mean, cube root of unity is the solutions to this equation, omega cube equal to 1, right? And on top of that, they are not saying omega is not, they're saying omega is not equal to 1, so you have this 1 plus omega square equal to 0. right? And if you take this, you solve it, you get some complex solutions. I mean, you will realize that you will not, you don't even need to solve that and find that complex solution, right? So the trick is simple. You keep multiplying this with omega. Okay. Um, so first is omega power zero, right? Zero, one, two, right? If you treat this one plus omega square, you multiply that with omega. What you will have is omega power one, omega power two, omega power three. So one, two, three. Again, you multiply that with omega, you get 2, 3, 4. You multiply that with omega, again, you get 3, 4, 5. Right? So these are the different possibilities that I got. Uh, if I keep multiplying with omega. And you have to use this fact omega cube is equal to 1 to simplify this. Right? So let's say you got 1, 2, 3. Omega power 1, omega power 2, omega power 3 is 0. But this is, you're throwing three dice. This one row can happen in 3 factorial ways. Right? So that's a 6. So in total, you have 1, 2, 3, 4, 5, 8 times 6. Why it is 216? Because you are throwing three dice. You have total 6 cube possibilities. Out of them, these are the events that satisfy this equation to be 0. That's why that is the answer. Might have missed. I don't know. I think I have exhausted all the possibilities. I might have missed one. Um, but yeah, I mean, to my knowledge, I haven't missed any row yet. And that satisfies this equation. If I miss say another row, you can just add 9 into 6 by 216. But I think I covered almost all. Any questions on this? Okay, so let's move to another question. Yeah, this is a bit complicated question. Um, right? Suppose you have a rope of unit length, um, and you cut that rope into three pieces. Right. So basically, to cut the rope into three pieces, you need to make two cuts. Right. And after you cut that rope to three pieces, what is the probability that three sides form a triangle? Right. So this is the question. And yes, as I said, this is a complicated question if you see it for the first time. So I'll go ahead and explain it. So 0 to 1, you treat a real line. Imagine real line as a rope. 0 to 1. One, because 1 is the length of that rope. Okay, and you made a first cut at point x and you made second cut at point y. So by definition, you have made y as greater than x, greater than x, right? And S1 denotes the segment 1, S2 denotes the segment 2, x to y, S3 denotes the segment this way, y to 1. Right? You just take the length S1 is x and S2 is y minus x, S3 is 1 minus y. Now for triangle, right, sum of any two sides should be greater than the third side. Okay, so I think I have I did a typo here, so let's try to solve the problem. Uh, okay, so you can see the screen, right? Whatever I am typing, you can see the sketch pad that I'm okay. So S1 is x, S1 is x, S2 is y minus x. I believe S3 is 1 minus y. Right, so S1 plus S2 greater than S3. S1 plus S2 should be greater than S3. That gets you x plus y minus x should be greater than 1 minus y. Right? That's how you get first constraint, y needs to be greater than 1 by 2. Right? This is one. Second condition is what S2 plus S3 should be greater than S1. Right? Y minus x plus 1 minus y should be greater than x. That's this can cancel out and x needs to be less than half. Likewise, you get the third constant as well. What is the third constant? Y minus x less than 0.5. Okay, so this is second and third constant. I'm directly writing y minus x to be less than 0.5. Okay, so you basically the idea is you have to plot the entire sample space. Out of the sample space, you need to choose the desired region. Desired region is governed by these three constraints: one, two, and three. Okay, let's see what is the entire sample space in the first place, right? Let's call this as x. This is y. Okay, so just to refresh, so this was our problem 0. We made two cuts x with y. This is my y. And by your definition of x and y is always greater than x, right? So we are x cannot be greater than 1 and y also cannot be greater than 1. Let's mark them. And on top of that, by design, you have introduced this constraint y is greater than x, right? So let's treat this as a 1 under 1. Okay. So this is a 45-degree line, and this is my sample space. Right. So this upper region is where y is greater than x. Okay, and this is my sample space. Now let's try to put down this constraint. Y has to be greater than half. That means um, you will have and x has to be less than half. Right. So this is 0.5. So x has to be less than half is this constraint. X needs to be less than half is the left side of it entirely, and y needs to be greater than half gives you this the above side. Right? So basically, what we got is now this square is what we got. Right? Out of this, we have added only two constants. We need to add this constant as well. Y minus x less than 0.5. Okay, so that line cuts straight away like this. So less than 0.5, so this, it will be this region. Right. So this is a triangle of length. This side 0.5 and the other side is also 0.5. So area is half times Half times half. All right. So what was the entire sample space? If you remember, that is y greater than x. Sorry, and this is your entire sample space, right? So this is half half, half into base into height, right? So one and one into half, right? So this is 1/4. Okay, so this is how you solve this problem. I think, yeah, this is the only I feel a bit complicated problem. Was another any questions on that? Why we got this thing? I think there's a typo here. Right? It should be one. It is not here. Uh, any questions, guys? Everyone clear, right? So we will move on to next question. Square. Um, the square, right? So basically, we are dealing with a rope with the length of one, okay, and we are making two cuts, x and y. So x it can take a value of one, and y also can take a value of one. It's strictly greater than x in our case, right? Because y is equal to what you get only one, right? So basically, because x can vary 0 to 1, y can vary 0 to 1, this is the space. Where is the space? But then y is strictly greater than x because you are cutting into three pieces, right? To get three pieces, y has to be greater than x. And yeah, that's why you got a triangle as a sample space. Adding triangular constraints, you get this desired area. Uh, that's clear. Yes. So let's go to another constraint. Yeah. So which of the following is a sigma algebra? I mean, it's again a straightforward question. Um, P omega is the sigma algebra, and second is not a sigma because one complement is missing, and third is also not a sigma algebra because one two complement fails. Only one is omega, trivial sigma algebra. Okay. Yeah, so this is also a little bit interesting question. I mean, I just want to manipulate these things. There are two events such that A union B probability is greater than 3 by 4, and A intersection B lies between 1 by 8 and 3 by 8. So you have these two statements. You need to tell whether they are true or false, actually. But yeah, they both are true, actually. So let's see how we have got this bounds on P of A is P of B. So, and I meant intersection here. Um, Sorry for that confusing notation, but yeah. And I meant by intersection. So P of A union B is P of A plus P of B minus P of A intersection B, right? And P of A plus P of B is just switching sides of this thing. You get A union B plus A intersection B. Because your A union B is at least 3 by 4 from this question, right? 3 by 4 plus 1 by 8, it is greater than or equal to 7 by 8. right? Um, yeah, A union B is at least 3 by 4 and A intersection B is at least 1 by 8. That is what we are using here. 3 by 4 and 1 by 8. That's why it is 1 by 8. Okay. Okay, moving to second statement. Yeah, same thing. Write down P of A plus P of B. And this is P of A intersection B is less than 3 by 8. We have utilized that fact and expanded P of A intersection B as this first line. P of A plus P of B is less than or equal to 3 by 8 plus P of A intersection B. Can someone tell how we have got this? What is the fact we have used here? Cool, yeah. So P of A union B cannot be more than 1, right? It is less than or equal to 1. So that's why, yeah, you just need to substitute less than or equal to 1 here, and 3 by 8 plus 1 is 1 by 8. Okay. Um, I think this is the last question. Um, now, suppose we have 5 good fuses and 2 defective fuses, and they're mixed up. To find the defective fuses, we test one by one at random without replacement. What is the probability that both the defective pieces are in the first 2 tests? Right. So, what the question is, we have 5 fuses which are good and 2 which are bad, and to find the defective fuses, the protocol that they are using is they are testing it serially one by one, and if they are mixed, we don't know. And you want the chance that what is the probability that first, when you pick the first, you ended up with a defective piece. When you pick the second, you ended up with the defective piece. Right? What is the probability? So simple, a desired event is A1 is defective and A2 is defective. Here one denotes the draw, and that is by using conditional probability, you write down like this: P of A1 is defective, and then A2 is defective, even A1 is defective. What is the probability that A1 is defective? Right? So you have to pick those two out of seven, right? That's 2 by 7. Now this is a bit interesting. Um, it's not um, why this is not 2 by 7. Why it is 1 by 6? So what if what if I, because they are not because they are replaced with they are not replaced, sorry, right? The total number of balls here are out of 7 there are 6, and because you have only one, and you already, your first uh, outcome dictates that you have done with one defective ball, and you know that only one more defective ball is remaining. That's why the numerator is 1, and there are out of 6 possible choices, only one is favorable, right? That's why it is 1/6. And the desired event is product of 2 by 7 and 1/6. What if you had replaced, right? It's just 2 by 7 square. I mean 2 by 7 whole square. Um, so yeah, that's all I have for today. Any questions? Let me stop the recording.